Our next speaker tonight is Professor Andy Sturman. Now, Professor Andy Sturman's been involved in teaching and research for more than 40 years at the University of Canterbury, where he was pivotal in establishing a strong national and international reputation for the study of weather and climate. For over 25 years, he led a research group in regional and local scale weather and climate, investigating atmospheric processes and complex terrain through the application of a range of modelling techniques. A major contribution of his research is in the development and application of innovative techniques to the solution of practical problems, particularly in relation to air pollution, wind energy and agriculture. The impact of his research has ranged from providing policy-relevant scientific advice to regional councils, such as mitigating poor air quality, to developing methods for applying models to wind energy resource assessment for a sustainable future. Professor Andy Sturman was awarded the inaugural Kidson Medal of the Meteorological Society of New Zealand in 2003 and has presented at a range of international conferences. He's currently serving on the advisory board of a major project investigating adaptation of the European wine industry to climate change. His interest in addressing real-world problems has also involved him in commercial consulting that has brought significant amounts of funding into the University of Canterbury, and he's published widely in international atmospheric science journals. His research has also had a profound influence on the way that climate science is undertaken in this country. So Andy tonight is going to give us a presentation on the impact of the climate-sensitive sectors of the economy. Ladies and gentlemen, Professor Andy Sturman.
So, yes, I was asked to talk about the impact of climate variability, particularly in relation to the economy, and that's an area that I've been working on over a number of years. So let's start by saying that effectively I'm going to talk about three different things. The first part, I'm going to make some general comments about climate change impacts. Then I'm going to zoom in on the Canterbury and the Christchurch region and talk about some of those activities that are perhaps more sensitive or more likely to be impacted by climate change. And then I'm going to spend the rest of the time focusing on a case study that my French colleagues over there with myself have been working on in relation to the wine industry and how that is closely related to climate, and obviously climate change has significant impacts on it. So let's just start by talking a little bit about what we mean by climate change impacts. And this little quote here from Gaudi and Viles is quite telling, in that basically humans act with intent but often without knowing the impact of their actions. So basically we don't go out there to stuff up the environment. When we drive our cars and whatever we're doing out there, pumping out air pollution or greenhouse gases or whatever, we not actually thinking about, hey, let's go out and cause a nuisance. So all of those sorts of impacts that work their way through the atmospheric and oceanic systems and have an impact on us are inadvertent. They're not something that we went out to start. The other thing to remember is that impacts range from global to local. So Adrian's already talked about models that are generally run at the global scale. But people from the regional council want to ask, they want questions at the local scale answered, and they can be quite complicated. And quite often you go and look at the literature about global climate change, and really you're scratching your head in relation to how does that affect me, how does that affect Canterbury, how does that affect New Zealand. But of course everything we do at the local scale contributes to the global scale, because we're all contributing to a global problem. There's also frequently there are time lags between different components of that impact that we have on the environment. For example, the ozone hole issue, there's basically a 10-year time frame a time lag between the emissions that we produced down here that ended up in the ozone hole. So it basically means that even if when we stop doing something, it may take 10 or 15 or 20 years before it actually has an effect. And also impacts can be direct or indirect. And some of those, as Helen has already talked about, are indirect. So climate change itself is not causing directly the processes that take place at the coast. They're also linked in with other processes. And of course they may involve, and I've just grouped these three together, environmental hazards, all of the sorts of things that you read about in the media, heat waves, storms, floods, droughts, etc. And that includes impacts on human health. And secondly, resource availability and of course environmental quality. And that relates to the broader issues of biodiversity and water and air quality. So there's a number of aspects of impacts, and I've tried to summarize it in this diagram. This is an early diagram from a book that my colleague over there and I are writing at the moment for Oxford University Press. And you can see over here on the left-hand side, we've got climate change, this global scale issue, global warming that everybody talks about. And generally, we talk about, as we've already seen, we tend to focus on particular variables. Temperature and precipitation are the two key ones, but Adrian also mentioned wind as well. But there tends to be a priority in relation to temperature, secondly, precipitation, and then there's a lot that is talked about in relation to general storminess. And you can see the range of impacts that can occur in any part of the globe, from human health impacts, agriculture, aquaculture, food production, water issues, coastal ones that Helen has already talked to us about, and then more generally ecosystems, etc. at the bottom. So in addition to the physical science side of things that Adrian has talked about, there are also these reports put together by the IPCC. This one was from 2007, that focus on impacts and adaptability. Because before we can move on to the next stage, which Bill is going to be talking about, the adaptation, how we adapt in a region like Canterbury, we have to understand how climate change is currently impacting our climate and how it may well impact into the future. So how do we assess impacts? Well, as I mentioned, there's this focus particularly on temperature increases or decreases in precipitation and extreme events. And a lot of the information provided by IPCC and other groups around the world are very much global in scale and very much average. So the sorts of temperatures that Adrian showed on his diagram were mean temperatures. They didn't really tell us much about the sort of temperature variability at the local scale in very short time frames and also over very short distances. So quite a bit of the work that we're interested in doing is actually zooming downscale, providing information that's relevant to regional councils and people in the community who want to make decisions. The other thing we have to remember is that the vulnerability or adaptive capacity of different regions, such as Canterbury, can vary in relation to climate change. So some regions are more robust than others, and when we're looking at a particular industry, whether it be, for example, the wine industry, we need to try and understand that relationship between climate and viticulture in this case, before we can evaluate how robust that industry is to a small amount of change, and how much change would it make for significant impact to occur. So let's have a look at some direct impacts. So they're mainly associated with some of the sorts of things that, that Adrian has talked about. If it gets much windier in Canterbury, as is suggested by some of the model output, then quite clearly driving along the road, particularly in that region just from Burke's Pass into Tekapo, will be virtually impossible, because I've been along there and I've seen the remains of caravans and things littered along the side of the road. So, so quite clearly there are those direct impacts of climate. So we choose any of the climate variables, we look at, for example, temperature. It can have a direct impact on human health. So for example, in 2003, I think it was, a heat wave in France was supposed to have killed many thousands of people directly as an impact of the increased temperatures. But we also have indirect impacts, and those are the ones that are only indirectly connected with particular climatic characteristics. And of course, the one we've already heard about is sea level rise, and that's typically associated with land-based ice melting, and secondly, thermal expansion of the sea. So you heat the water up, it expands, and so the sea level rises. And similarly, if you melt the ice on the land, it ends up in the sea, and so the sea level rises. If you melt the ice around the edge of Antarctica, the sea level is not going to change, because basically that ice is sitting in the sea already. So those are the two main sources of indirect impact due to changing temperatures, increasing temperatures. Most health effects are indirect applications of climate change. So we've already talked about heat-related ones that are much more direct, but heat also allows different diseases and vectors to occur. So people are already getting worried about the Auckland region and dengue fever, malaria coming through vectors arriving in that part of the country. So we should be worried about those sorts of things. I think, luckily, here we are in Canterbury. It gets cold enough in the winter, probably to kill them all off. So we don't need to worry too much about the nasty mozzies. But we do need to worry about things like water quality and quantity, and also land use suitability, because if we get climate changing, then clearly the sorts of plants that we produce, the different crops we produce, may well be no longer adapted to the climate, and we may have to look at other types of crop. But also associated with that is the occurrence of plant diseases or crop diseases. And we've already seen things like myrtle rust and things coming into New Zealand. Well, how did they get here? And what sort of control does climate have on their spread? So there's all sorts of biosecurity issues associated with that. And changes in the hydrological regime. So if we have generally warmer conditions, then we're going to end up with more rain and less snow. So then when we get precipitation, it's going to occur as rain rather than snow. And most of us, if we know how the regime of the Waimaka area works, I know, because I live the other side of it, that it generally has higher levels in the Waimak when the snow is melting in the mountains, and that's generally in the springtime. But of course, if it was going to rain all year round, instead of the snow arriving in the winter and staying in the mountains until it melts the following spring, you end up with a change in the seasonal distribution of water available on the Canterbury Plains down here. So there are all sorts of complexities within these sorts of impacts. So just to give you an illustration, and again I thought it was appropriate, as Helena was talking just before me, was the coastal one, is that we can use a diagram like this to indicate the interaction between direct impacts and then indirect impacts associated with sea level rise on the right-hand side here. So there's all sorts of different connections between different aspects of our environment through, as you can see at the bottom here, storm, drought, wildfire, erosion, landslides, avalanches, etc. And they link with some of the processes that Helen was talking about in terms of salination of coastal waters and so on. So key considerations then, we have to remember, as I think Adrian just briefly mentioned, that basically climate change impacts can actually be positive as well as negative. So it depends where you are. There are winners and there are losers, and I'm going to show you an example in which actually Canterbury region actually turns out to be a winner rather than a loser. Our economy is also sensitive to the impacts of climate change at overseas places. So if the climate gets too bad in France for them to produce good wine, and it gets better here to produce wine, we're going to actually benefit out of this. So we have to be aware not just of what's happening here, but what's happening in other places, either competitors or places, markets that a new opportunity may arise. Also, I'm reading through a lot of the guidance and other material that's produced over the last 15 or 20 years. A lot of the statements tend to be rather vague and sometimes contradictory when people try and take this global information and project it down to the local scale. So, and finally the point at the bottom there is that evaluating impact, we have to understand the mechanisms behind these impacts before we can develop adaptation strategies. And it can be extremely difficult to do. And I've just listed here, under these headings here, perhaps in almost priority order, of the main areas that Canterbury needs to be thinking about in terms of future impacts of climate on the economy. So obviously starting with agriculture, horticulture, etc. Tourism, recreation, obviously we want an environment that's got ski fields in it in the winter time, and of course there the snow is again sensitive to change. But there's all sorts of other issues, wildfires. We had that really nasty fire at the beginning of last year, and we seem to have had an increasing frequency of those sorts of events. Now what I just want to do now is just show you a simple case study that perhaps illustrates some of the difficulties associated with understanding climate change impacts in order to develop adaptation strategies. And it's in viticulture. So climate change impacts can be positive and negative, and I've already mentioned that in relation to other parts of the world. Because they affect the changing climate affects the way in which the vine develops through the growing season, from earlier bud burst, flowering, etc., under a warming climate. It also can change the occurrence of climate risks. And there's quite a lot of documentation that suggests we're going to get fewer frosts. But it also, when it comes to wine production, can change the whole characteristic, the flavour of the wine, the reason why somebody buys this bottle of wine rather than another one. And this diagram is useful in bringing together the climate and the viticulture, the other components of viticulture, in order to produce a wine of good quality. But overseas, they've been looking at the different grape varieties, as indicated in this diagram with these bars going across. This represents the average growing season temperature range associated with different grape varieties, from the warm varieties down here to the cold ones over there. And the concern in Europe has been that these three regions here in France and Germany have shown an increase in average temperature, average annual temperature through the growing season. And so that each region is basically eventually unable to produce in some instances, the wine that it used to make, or the particular grape varieties it used to use for making wine. So there's quite a bit of international concern about these problems. And then they've basically taken this model, this average temperature of the growing season, and then used the sort of information that Adrian's talked about to project what the temperatures will be like in the future, and therefore what the future potential for grape production for wine is likely to look like. So these red areas here are areas where in future they won't be able to produce the same wine that they've been producing before. And the blue areas are the new areas, the novel areas, where we will be able to produce wine. And you can see there's a migration of wine zones through Europe here, for example. But if you look at all the different wine-producing regions of the planet, there's only one that doesn't seem to have any red on it, and that's New Zealand. And you can see it's actually got quite a lot of blue, and a whole chunk of it is right around Canterbury here, around Christchurch. So this international assessment, which is a fairly broad brush assessment, is suggesting that New Zealand is actually a good place to develop a new wine industry when comparing with other parts of the world like the Australians and so on. And again, this diagram here shows that there's New Zealand. It's one of only 3 parts of the world that's actually going to have land that has future potential for developing grapevines. So when you look at the grape varieties we produce in New Zealand, they're these Sauvignon Blanc and Pinot Noir, the 2 most important ones. And we've done some work to map those, basically taking those bars, those mean growing season temperature ranges, which is up the side here for Sauvignon Blanc. So this is a good range apparently internationally for growing Sauvignon Blanc. If we map that across Waipara, you can see Waipara's not too bad. It's a little bit cool, but with a 1 degree increase in average temperatures, you can see Waipara gets rather better, more ideal. It's sort of optimal in the middle of this range. But 2 degrees, it rather gets a little bit too hot for Sauvignon Blanc. So we can apply these little models. These are the sorts of things I play around with, is developing models to look at small-scale variations in climate and how they relate to basically land use suitability for different crops. If we look at Pinot Noir, now that had a different bar covering a different temperature range from 14 to just over 16. At the moment it's actually up the warm end for this region here. This is Waipara again. If we increase the temperature by 1 degree, it's gone. The white area is off the range. So basically so you can see that Pinot Noir is much more sensitive to change than Sauvignon Blanc in Waipara. Now if you can think of applying that same sort of principle to a whole range of different crops in Canterbury, you'd then have a resource for developing adaptation strategies, the sorts of things the regional councils and people would be interested in. So there's 2 degree increase and it's even worse. And the other thing is that over time, along the east coast here, there's been actually an increase in frost. So although people suggest that with the higher mean temperatures, number of frosts should drop, well actually from 2 independent sources from our work, which created that diagram there, showing for Christchurch and Blenheim, up the east coast here, we had more frosts since about the 1950s. NIWA produced this map here, also showing over a relatively recent period that there are some parts of New Zealand that too have had an increase in the frequency of frost. So you scratch your head and say, well, that's important for producing wine. You know, why don't we know more about this, and why aren't we using this information to give an idea of how to develop adaptation into the future? Basically, it's because the temperature range, this is the daily temperature range at Christchurch and Blenheim, averaged, is increasing over time. So we're getting lower minimums and higher maximums. So why is that? So then I scratched my head and I thought, well, what sort of weather produces low temperatures and high temperatures on a given day? And we all know in Canterbury, it's those lovely, crisp, cloudless days when lots of energy can come in to heat up during the middle of the day, but all that energy gets lost overnight. So you end up with negative temperatures at night. Okay, so then we say, okay, well, why are we getting clear skies? Must be getting less cloud. It's like a detective novel. You just work your way back, asking one question after the other, and you find that, blow me down, if you take one of these standard pressure pattern, daily pressure pattern or weather system classification systems and plot the data over time, there's actually been an increase in the number of ridges and highs located over New Zealand, which doesn't surprise anybody because those are the ones that give you the sunny days. Okay, so everything seems to be working here, but why? And then we come back to one of Adrian's slides. Thank you, Adrian, for putting it in. Also, in conjunction, obviously, if you increase the highs, you're going to decrease something else. So we're actually increasing the lows and the troughs. Although at the same time, there is a slight increase in the westerlies, which is something that Adrian mentioned just before. But going back to that lovely circular diagram that Adrian showed, looked like a donut. Well, here's another one that looks like a donut, because around the outside here is the frequency of anticyclones. So those are the weather systems that produce that strong diurnal temperature change. And as Adrian mentioned, that over time, all of those weather systems, he talked about the low pressure systems, the storm systems moving in towards Antarctica. They've tended to move poleward. Well, of course, if they're moving poleward, then the anticyclone is going to move poleward as well. And that's why we're getting more anticyclones. So here we've got a complicated problem. We've got global warming happening. Okay, it's increasing the average temperature of the planet. But at the same time, because there's more energy happening, there's more dynamic things happening in the subtropical regions, it's pushing all the circulation systems away from the tropics towards the poles, and so that we end up with more anticyclones. So on the one hand, we're told at global scale we've got warming temperatures. The vineyard people are going scratching their heads and saying, well, how does that relate to all these frosts we're getting? And so when we move down to the local scale, we really need to get down to this sort of detail to work out the relationships between what's happening at the large scale and the smaller scale. So there's an idealized picture of where our weather systems tend to be. These are the Southern Ocean lows. So we're getting more of these heading, basically being located over New Zealand. And blow me down, I discovered in February this year that it happens in Australia too. Or parts of Australia. So these little blue areas here are parts of Australia that they're getting more frost. And they're affecting their crops, their cereal crops. So there's just a few summary points to end up with. I've probably run out of time, have I? Okay. Yeah, so what I've tried to show you is perhaps that the world is actually more complicated than some of the generalizing information that filters through to people through the media. We know there's global warming happening. We know the planet is getting warmer. There's ice melting and all sorts of other things happening. But when we drill down to the local scale, it can be really, really complicated in terms of the sorts of variations that we're dealing with. And I'd hate to work for Environment Canterbury because it's such a problem of trying to provide people with some certainty as to what's going to happen in the future and how to adapt whatever their industry happens to be from here on over the next 10, 20, 30, 40 years. And as the second point, this problem is actually identifying when these impacts are actually happening anyway. There are obviously direct and indirect factors involved there. But I think that the main plug really is that we really need to try and understand what is actually going on between the global scale and the local scale, and deal with practical problems such as whether it be the wine industry, other crops and things around the place. So I'll leave it there.